Welcome to the networkd session. Can someone please give me feedback on RFC whether the video is working? Well, that still says starting soon. Okay, but that means it's just lagging. It's not cutting us off. All right. So yeah, welcome everyone again, and special thanks to Tom Gunderson, who is the author of systemd networkd, for joining us today at this late hour.
Thanks for inviting me.
Yeah, so this session is about considering. Okay, sorry. So the public video is working now. I just heard myself.
That's what that was.
Right. So we want to investigate today whether we can replace our current ifupdown infrastructure and replace it with systemd networkd. Apparently, that has been suggested by our benevolent leader, and apparently also by Snappy and Cloud folks. So I guess we want to investigate the current status of networkd in terms of feature parity, and also how we can move from our current ifupdown-based systems to networkd. So I think we want to explicitly exclude desktops here. As far as I understand, Network Manager is still today's recommended management interface for desktops, because it has like Wi-Fi's and 3G and all of these things. Would you agree, Tom? Or?
Yeah, we haven't done any work on Wi-Fi or 3G in networkd, so that's yeah, not something we try to support at the moment.
Right. So this is mostly targeted at servers, cloud, Snappy, where you have like where Wi-Fi and mobile data is not. Yeah. Okay. So does anyone of you have any particular requirements? What we should like set out as a goal, or what we expect from this?
So I think it's two areas, right? One of them being very minimalistic core plus cloud and server, and then we need to actually see if we can cover the use case for what we already ship. Right? Why don't we start with the cloud guys, just to make sure that, because I think that this session comes actually from their requirement, right? So let's just make sure that this supports what they need. And then we can talk about the use cases that are not covered, as you said, VPNs, Wi-Fi, 3G, mobile data, and so on, that we're actually covering with Network Manager and external plugins we use.
So anything that's using Network Manager today is out of scope for this conversation. Okay. We're really only talking about the server use cases. We're not looking at replacing Network Manager with networkd anywhere. That would include on, for instance, Snappy Personal. I think it's we're not in a state where we would want to migrate that at the same time. So we're really just looking at ifupdown versus networkd. And I would expect that we would integrate networkd. Well, in fact, I think networkd is already integrated in a way that if Network Manager is installed, it won't do anything. We just need to make sure we retain that capability going forward. So anywhere we're using Network Manager, we would continue with Network Manager.
I think it's rather the other way around. Just like ifupdown, the way it should be is that Network Manager ignores interfaces which are configured by networkd, right? Isn't it? So how does this look like, Tom? So how does Network Manager know that an interface is not to be touched by it, but by networkd?
So at the moment, the way it works is that networkd will not grab any devices unless explicitly configured to do so. And the assumption is then that you also have configured anything else in the system to not grab it. So there's no further between Network Manager and networkd apart from that. But if I understand you correctly, if you just want to do this in servers and on the cloud, I suppose you will not be running Network Manager and networkd simultaneously on the same system anyway.
Yeah, that's right. I mean, my concern was more like if someone enables networkd on this desktop and configures, for example, the Ethernet interface. At the moment, we have well, I think it's even an upstream Network Manager. It has support for checking the, what's the Reddit equivalent? So some checkconfig or ifupdown scripts configurations, and it won't touch interfaces which are configured by it. That's especially important for Ethernet interfaces, where a network manager just automatically connects.
Yeah.
It's less of an issue for Wi-Fi or VPNs, or which you have to explicitly set up.
So we have an API in networkd that they could, in principle, hook into to check if we are going to be grabbing the interface. But I don't think they currently do that. So that's something we have to check with them, with the management guys. Currently, I'm using both on the same system all the time, and it works just fine. But yeah, if you want to guarantee that, like a feature to be able to mix and match, then you probably should check that out.
Mm-hmm. So I guess I'm not terribly concerned about that being a priority anyway, because if you're running Network Manager today, it's because you're on a desktop style install, a desktop or client system, phone, desktop, whatever. We're not going to be configuring networkd on those systems. If somebody has already configured ifupdown, they can continue to use ifupdown for managing their networks. And that integration with Network Manager is already there.
Just to add, when we have tried to make it possible to mix and match Network Manager or other things on networkd, but ultimately I don't think it makes much sense to have several network management solutions running on the same system at the same time, because you have some global state that you have to manage that is across all the interfaces, and to have some managers grabbing some interfaces, it might work. It works now, but it's not a very elegant solution. So I wouldn't really focus much on that. I will say that either you use one or use the other one.
Right, and I think we for various reasons we do have, so ifupdown plus Network Manager is an existing configuration that dates back to before Network Manager could support VPNs and things like that.
Okay.
But it's existing systems, and we will have to deal with a migration there at some point if we think we're going to move to networkd. But I think we should just say, for right now, we're not configuring networkd on the clients. We're continuing to use Network Manager. If individual users have ifupdown configurations, those will continue to work together with Network Manager the same way they do today. And eventually, we would look at whether networkd could provide a complete solution.
Makes sense.
Right. So I think there is two rather foundational issues which are relatively independent of particular network types or interface types, which I would like to discuss. So the first is, as far as I understand, networkd is pretty much comes bundled with resolved-d, right? So just for the record, like resolved-d is a kind of similar to what we have in resolve-conf. So it's a creator of a dynamic etc resolve.conf. So with resolved-d, that is a symlink to run systemd resolve.conf, which gets put together through a dbus interface, I believe. So clients like networkd and potentially others could tell resolved-d, here is a new interface, and my DHCP said use this name server. So resolved-d gets all these requests and creates the resolve.conf for you. Currently, we have the Debian-specific package resolve.conf, which is working in a similar manner, except that it's working through shell scripts. So whenever we if up an interface, then a shell script gets run, which runs all the hooks, and then it assembles the resolve.conf for you. And I think the two are relatively incompatible within one another. So I did not see an easy way how to, for example, tell resolve.conf to update its configuration whenever networkd, whenever resolved-d wants to update its state file, or the other way around. So I think we have to pick one. And then, of course, if we drop a resolve.conf, we kind of have to port everything that currently puts into resolve.conf, which is not that much, but a bit. We have to simultaneously make the talk to resolved-d as well.
So shall I add something how it currently works?
Please, yeah.
Yeah, so currently networkd will expose through a C API all the information it has about DNS servers, and it's up to, but networkd itself will not configure anything, it will not write a resolve.conf or anything like that. And anyone could consume this information if they want to. And at the moment, the only consumer we have is resolved-d, as you mentioned. And actually, resolved-d is it's a proper DNS resolver, so it will actually resolve addresses, and it will exposes over dbus. But one feature it has is for backwards compatibility, it will generate a resolve.conf file based on the available information. And this file is placed into run, and if you want to use that as your only resolve.conf, then you could symlink it from etc resolve.conf to the file that you write out in run if you want to. So you're not obliged to use this as your only resolve.conf if you don't want to. You could use you could still use the solution you have now and hook into the file that you write out in run or something like that. I mean, there are several solutions, but I obviously think that resolve.conf is resolve.d is a much better solution than what currently exists. So that's probably something worth looking at for resolving in general, not only for generating resolve.conf.
Yeah, I agree. I mean, what I like is that it's a kind of a very small thing which gets us both. We currently use DNS mask as a local DNS resolver and resolve.conf to have lots of shell scripts to create a resolve.conf files. So, and I like that it's very small and very fast, and even DHCP is pretty fast, and it does both for us. But it's still a migration issue which we have to consider. So I wanted to clarify the situation here.
Right. I think it is something that we should evaluate, but I want to make sure that switching to resolve.d is taken separately from networkd, so that adopting networkd isn't caught up on the migration issues we might have with resolve.conf versus resolve.d.
Yeah.
Because while there's not a whole lot that integrates with resolve.conf, there are a number of corner cases, and it's going to be some piece of work to make sure we handle everything correctly. For instance, local resolvers, bridge resolvers for VMs and LexD, although at the moment that doesn't work all that well with resolve.conf, but that's another matter.
Yeah, I mean, if we have any simple way to run networkd and somehow catch whenever it wants to update DNS and plug that into resolve.conf, then we would have two independent transitions, and that's certainly easier to do.
Yeah. Now, so actually, how would that work? So I heard you say that there was a C API for querying the resolver state from networkd?
Yeah. So basically, you subscribe. Well, there's a C API where you can subscribe to network changes, and in particular, you can change to the DNS configuration, and then you get notified about the changes, and you take it into account. So if you want to use this from a Bash script, obviously, yeah, it's a bit of you have to do some work. You could, I mean, I shouldn't recommend it. I mean, the way the thing works internally is through state files, pure text files in run. So in principle, you could just hook into those from Bash script and read them out. I mean, but we don't make any API guarantees there, so that's a bit dodgy. But that's something to keep in mind. I know that the core OS used that at some point because they used this a long time. So that's something that's possible to do. Probably it would be better to make a little wrapper in C and hook it into your Bash script. But
yeah, so the resolve.conf model that we have today relies on those things which provide DNS information, DNS settings, to call some sort of a hook and manually drive resolve.conf
right.
and push that information. Is there any sort of...
So what you could do then is to write a little daemon in C that subscribes to networkd and then pushes the changes to resolve.conf. That's really my suggestion.
Can I ask a slightly related question? Ifupdown has support for up, pre-up, down, and pre-down arbitrary scripts and arbitrary bash commands, basically. Yep. Is there an equivalent to that in networkd?
No.
That would have been my next question.
So, yeah, we do not support any hooks. So if you want something supported, it should be, at least for the time being, we have only supported native things that you put inside networkd itself. I'm not completely opposed to extending this, but I would like to see a really good use case, and so far we haven't seen anything.
So I mean, our use case is firewalls. Our firewalls, or every firewall we have has up scripts. Some of them have down scripts, and the more complex ones have pre-up scripts. Yep. Because the firewalls tend to be tied to, or can be tied to interfaces coming up.
Yep.
How do you guys recommend people handle kind of complex firewalling with networkd?
So we are working on firewalling at the moment, but we haven't done much. Nothing is finished yet. So I don't have a good solution at the moment to how to integrate it fully. But my recommendation would be to set up your firewall before you start the network D, so you have a completely separate thing. But if you want to have something dynamic, then we don't have a solution yet. That's something we are working on.
Yeah.
And, yeah.
I think the more complex case is actually the post-up script. So we have like probably dozens of packages which add stuff into ifupd, starting from simple things like restart OpenSSH so that it picks up the new interface, to rather complex things like OpenVPN, doing some automatic startup of configured tunnels and so on. But my gut feeling is like network D is already relatively close to system D, and so how far is that integrated? I noticed that when you set up a .network, like not a unit, it's a bit like a unit. If you set up for example, ETH0 with the HTTP link, you get a .network unit in network control. Can you somehow trigger system D units based on that? So can you say we start a unit whenever a network comes up or gets down?
There's no integration there at the moment, and we don't plan it at the moment either. So just to mention that to do post-up scripts is actually pretty easy. I mean, you can make a bridge similar to what I suggested for the DNS setup, that you have a bridge that listens to events and then reacts accordingly. So that's not really a problem. The only problem I see if you want a pre-up script that actually delays network D. So if you want to block network D from bringing up an interface until you have done some work before, that we currently cannot support with the current API. But if you just want to react to something and do something afterwards, that's relatively easy, just making a bridge.
Okay. Well, that's a good point. I mean, if we have this daemon anyway which describes the changes, this could just call the ifupd script as network manager and ifupdown do as well. I think that would be the biggest transition issue that we have, because like changing all the packages in one go to deal without ifupd, that doesn't feel very simple. I mean, it might be enough for a fixed use case like Snappy, where we have precise control what happens, but on servers and cloud, I mean, especially on cloud, there is all kinds of things people install.
Yep.
Okay, so for the pre-up thing, would you think that integrating the .network and .NET-Dev, well, how do you call this, network D devices into system D units is something which would be a good idea, or do you want to keep them apart?
So I would prefer to keep them apart, and I would prefer not to have a too complex state machine in network D that we don't allow arbitrary hooks to do arbitrary things, if it's at all possible. Yeah. So as I said, I'm not completely close to the idea, but if we can just keep it simple and separate, I would really prefer that. So, well, we'll see what kind of use cases come up, and if people have strong requirements that requires it. But so far, the only really convincing arguments I've heard for arbitrary hooks is to support legacies that to existing software to support that, and I don't think it's worth it just for that, to be honest.
Okay.
Sorry, can I ask a dumb question? What arbitrary hooks? What makes that network D? Why does that make it so much more complex for network D? I'm just a dumb non-programmer and I don't understand.
Well, it's basically about the state machine that you have. If you currently, we know all the states, all the things that can happen. We know the things, how things can possibly react to state changes on your system. But if you allow anything to happen as a result of anything, then I mean you no longer have any idea how long something should take or what could possibly happen. So it's really a much harder thing to debug and argue about. So I mean, we saw this same thing with things like UDEV and so on, where we can hook in arbitrary things, and then it's suddenly very, very hard to make changes to it because you don't know what people are doing. You don't know what people are putting into this stuff. So as soon as you open up to arbitrary things, you cannot change anything basically because the people can do whatever they want with it. So if we can avoid it, we want to avoid it. It makes our life much easier. I don't know if that answers your question.
Yeah, no, it does. Thank you.
Okay. So I guess for ifupd, like, does everyone agree that, like, for the transition, we should just write it to the daemon and just run the scripts as we have them today, and then we can solve for them one by one. Pre-up.d is certainly a smaller case, and we might just be able to, all the packages that ship a pre-up.d hawk, instead ship a unit which does the equivalent thing in network pre.target. So that firewall setups, etc., happens at the right time, which is network pre.target in systemd. So that might be feasible. But I think that's a work item, and we probably won't be able to say right on the spot whether this is feasible or not.
Mm-hmm. So, James, for your use cases with the firewalls, are you using pre-up or are you using up hooks, or what is your use case?
The vast majority are up and down. There's oddball pre-up cases. I'm desperately scrambling through hundreds of machines trying to find them. But there have been some pre-up cases, but they're very few and far between. And some of them fall out of if up down's kind of non-linear nature over the years, like the changing order of which it's run things and stuff like that. So I'm not sure. I don't think I have a convincing valid use case for pre-up. But one thing, Martin, you seem to be talking about like the package shipped ifup.d and so on, but just bear in mind there's also the interfaces file itself that the user controls can have arbitrary ups, downs, etc. And I'm not sure how, if at all, we were planning on handling migration for that.
I use that quite heavily, actually.
Well, I'm not sure whether we are ever able to migrate an existing ifupdown system to networkd. I think we are mostly considering cloud instance and Snapd here, where we basically start from scratch. Because, as you say, when we have no idea what people do with their interfaces, HTTP network interfaces.
Right, but Martin, we don't want to be in the situation of supporting 3 different network managers indefinitely, where we have networkd for cloud instances, ifupdown for classic server, and network manager on the desktop. That's not really tenable. We don't want there to be 3 different ways to configure networking for Ubuntu. So whether or not we provide an automated migration, we should know that networkd, if it's going to be our server network solution, that it has the features that we need for the use cases that people have today that they need to deploy Ubuntu on. Because also, even if it's just snappy, we're talking about things like firewalls. Well, we expect Ubuntu Core Snappy to be usable to build firewalls, embedded devices of all kinds. And so if there are cases that we need to figure out how to make that work, that's something we should be looking at rather than kicking it down the road.
Yeah, that's right. I'm concerned that we have 2 systems here with and neither dominates the other. So ifupdown has lots of features and hooks that we don't have in networkd, and vice versa.
Right. So I mean, here's the thing. I mean, as it stands today, even in my tiny little home network, the write-up on what networkd does wouldn't be enough to support the things that I do, and that's fine. But as Steve says, we can't support 2 things forever, or the goal needs to be convergence, and currently we are converged because we started from the same place. So if we diverge, the ultimate goal has to be that the thing we're choosing to diverge to will support everything we need down the road. And if we can't make that guarantee because we can't commit the resources to doing it, or because upstream doesn't like the things we do, or whatever, then that seems like a bit of a blocker to the entire conversation.
Adam, just out of interest, what does networkd not do that you use in your current network?
Well, it doesn't support wireless, and I run a bunch of APs.
Oh, sure. Sorry, I thought you meant a server case. Fair enough.
Well, no, those are servers because they're headless APs, so there's no network manager involved or anything like that. And that's actually a perfectly valid use case for Snappy as well.
Well, I mean, people actually have made networkd work with wireless interfaces. So you can integrate WPA supplicant into it. It's just not built into networkd. So I'm not sure whether this is an officially supported configuration for networkd, but I've seen people where it works.
So,
but it's of course a client, not an access point.
Shall I add some about the future plans? If you want. So it's definitely within our scope to support Wi-Fi. We haven't done the work yet. There are people who are working on it, but we haven't seen the code, so I cannot make any promises. But yeah, it's definitely within our scope, and if someone did the work, I would definitely accept it. And as to firewalls, obviously, we want to create a solution that can support firewalling. It's a very important feature. So that's also something we will absolutely want to support in the future. And now, exactly how it will work and how it will look like, we haven't all agreed yet how firewall support should be. But there will certainly be firewall support. So maybe it will not be exactly the way that you currently have your firewall set up, but there will be some firewall support.
Sorry, I might have missed this earlier. What's the control mechanism for changing network? Like, is there an ACL in place, or how do you control, like, who can change the network, which application can change the network configuration?
So at the moment, there's at the moment we only support static configuration, which means that you have your configuration files installed at boot time, and then that's what we pick up and we react accordingly. I mean, we will tear up and down the interfaces as things happen, but we will not allow to change the actual configuration on runtime. And the only reason for that is that we want to support this over. I mean, there will be a dbus API where we can change things, obviously. But before we will do that, we want to have KDBus so that we can have the dbus API available at all times, because network D is something that you start very, very early on during boot. So we don't want to have lots of hacks to be able to support the dbus not being around and then arriving later on and so on.
Do you guys think KDBus is going to get merged? It looks like it's a bit of a train wreck right now on LKML.
My opinion is that it looks there's a lot of emotional arguments on LKML, and the technical ones there are not so many actually. Out of the few hundred emails, I think there's probably one or two things to actually sort out, and I think we will get it merged eventually. And otherwise, I know that some distros are talking about just shipping it out of free, so we will get that at some point. And worst case, I have a plan B for network D. If we don't get KDBus anytime soon, I will put in the hacks to make it work without KDBus. But at the moment, that's the reason why I have delayed it, not working on the dbus side yet, because it will be so much easier once we have KDBus. So I didn't want to put any resources towards adding hacks quite yet. But that's obviously on the roadmap.
Yeah. So at the moment, you can think about it pretty similar to ifupdown. So instead of VT network interfaces.d, you write a couple of .NET and .NETwork scripts, not script configuration file, which declare which interfaces you want, set up tunnels and DHCP or not, and static addresses and so on. So from that point of view, it's pretty much the same. I mean, the syntax is obviously different.
Yeah, one thing I keep coming back to as I'm thinking this over, though, the idea that to be able to receive network events that we're going to have another daemon running on the system, I think that's a hard pill to swallow. I mean, today on servers we have 0 daemons running for network management, and that's a problem, that we don't have anything that owns the state and keeps track of it. If updown only manages part of the state, it can easily get out of sync with the kernel, and so that's not really a great solution, and that's one of the things that network D gives us. But the fact that we can't then subscribe to anything that network D is doing and any of those network changes without having to have another daemon running, that means that we've gone from having 0 daemons running on every system to having to run 2 daemons.
Well, just to clarify, you can subscribe to events. It's just that you have to subscribe. You cannot install hooks. That's what you can't do.
So how would we subscribe to those events without having to run a daemon that's subscribed to them, I guess?
I'm not sure exactly I understand the question. So the way it works is that there's a C library that you can link to, and it will give you an API where you can have a monitor that listens for network changes, network events. Right,
but I mean, you have to put that network monitor into something, and so that
so whatever your consumer of network events is, you have to hook it up.
I mean,
if that consumer of network events were systemd itself, that would be fine, because then we've got a thing that's always running and can consume the events for us and launch units. But I understand you said that wasn't part of the plan.
Yeah, I mean, we could always like just patch networkd to just do the two things we are interested in, like run if scripts and update resolve conf for the time when we don't yet migrate to systemd resolve d, of course. That's of course ugly. It's very like intrusive. But if we are concerned about the second daemon, that might be an option just for completeness.
Yeah, I mean that's how it worked. We never did the hooks, but for the solve-conf writing, that's how it originally worked. It was all done by networkd. So that's definitely something you could do.
So we've identified Wi-Fi as a thing that's not implemented yet in networkd, and that there are some server/embedded IoT use cases for that in terms of running APs.
And actually, I mean, running an AP is different than connecting to a Wi-Fi. So I think the latter is applicant, but running host APD, why is that actually concerned so much about which, like what part brings up your WLAN 0 interface? I mean, the host APD does right?
So it may be that there's actually, all the pieces are probably there, but there may be some integration work to handle that use case. And that my point is actually that I don't think that that's a blocker for switching to networkd. I think some of those integration things will be taken care of up the stack by people who are deploying APs. We don't expect Snappy Ubuntu Core to be an AP out of the box. We do expect people to be able to build an AP solution on top of it. But are there other server use cases that we think we need to make sure are covered? In the meeting description, we called out several things that we think are supported today. Bonding, VLANs, bridging. Are there any concerns with any of that?
Well, I played around with VLANs and bridges, and that works fine much. I mean, it's similarly declarative as an ifupdown. You just say I want a bridge, or I want to create 3 VLANs, and then form them together. It seems pretty straightforward to me. So the question of how well we can automatically translate an ifupdown configuration to networkd, that probably remains to be seen. But like in principle, that looks like feature parity to me right now. But just quickly going back to setting up an AP, I mean, from my point of view, that only touches host APD. So you say you configure your host APD to use these 3 interfaces, and you just don't configure them in ifupdown or networkd or network manager. So that I don't think this even concerns the discussion here.
Well, I don't know. The ifupdown host APD integration is actually really nice, but yes, there are other ways to do it. It's just a bit of a regression in the fact that you now have to configure in multiple places in different ways.
Well, in host APD's own configuration, yeah. I don't know how the ifupdown integration looks like now. I only ever used host APD like standalone by itself.
So the nice thing about the ifupdown integration is that it makes sure that the interface bring-up order is all correct. Because if you configure a bridge and then tell it that one of its children is a host APD thing and give it the host APD config file, it actually runs host APD at the right time, makes sure the interface is up, and then attaches it to the bridge, and everything magically works correctly.
Okay.
I will be very interested to see if that doesn't work currently with networkd. I will be very interested to get a bug report. I think that should just work.
Well, just work how? I mean, where would you call host APD? Because we don't have any hooks or anything where we could call it from a .network unit.
Sorry?
I mean, where would you call host APD in that scenario? Because we don't have any hooks in the .network or .net thing.
My understanding was that if you configure host APD separately and you just make it create the netev and set up the wireless connection, then you have a network file which you specify should apply to that wireless link and add it to the bridge. Then it should notice the link coming up and add it to the bridge at the right time.
Oh, this way, right, okay. Because you configure them separately and it knows which parts belong to the bridge. And so it already knows when the interface goes up?
Yeah. Okay. So that's, by the way, similar to if you want to use Wi-Fi via Wi-Fi client today. You configure the WPS applicant in a normal way, and the networkd will see the thing coming up, and it will do DHCP on it. The only thing that doesn't work at the moment is to be able to change your settings, say to have a DHCP on one wireless network and then a static IP on a different wireless network, because networkd at the moment doesn't distinguish between different wireless networks. But that's something on the roadmap. But otherwise, it just works fine. So if you always use DHCP, then it just works.
Okay, so the ifupdown scripts and resolved were my two big discussion points, but I think we sufficiently dwelled on that. So should we move on to some other concerns, maybe from the cloud or network folks, or any particular requirements which we need to discuss here?
Yeah, actually, just a quick point from the server team. So we have some cloud bootstrap tools, like Curtain Installer, for example, which needs to get its cloud config with a description of networking config for the node. Basically, like I want to set up 2 Ethernet ports and create VLAN and create a bridge and so on and so on. And we basically need to do this networking config by reading this configuration file and doing some work. For this cycle, we plan to emit some network interface files for ifupdown. And what we need to do with networkd? Do we still need to emit some configuration files like netdef, link, network, and so on, or we have some kind of a simplification like API for this or something like that?
At the moment, it's just creating files. So, as we discussed earlier, we don't yet have a dbus interface to do this, but I guess in your scenario, it would actually be easier to create files than talking to a dbus service, I guess.
Okay, and to me it looks like for this cycle we need to emit ifupdown files, and then we need to switch to networkd files. Is it correct?
Well, it sounds correct to me. I'm not sure how fast we can make that switch. So depending on how early you need that feature, we might need to do that. It probably depends on the complexity of what you need to write out. So if you just have like 5 standard use cases, then it's probably relatively easy to translate that into ifupdown configuration versus networkd configuration. And if you again have arbitrary hooks and the user can how do you specify, like, what does the user specify there in terms of the cloud config?
Well, not user actually. We get it from MAS, which is basically a YAML file, which describes all this network configuration.
Yeah, so if I understood Oleg's question, he asked whether it should be emitting ifupdown snippets this cycle and networkd snippets next cycle. I would say that ideally we would be on track to be emitting both ifupdown and networkd snippets this cycle. And if there needs to be some logic in Curtain to detect which one is active and then write the corresponding snippet for the device in question. But the goal is that this cycle we would have networkd available as an opt-in, and that certainly means that things up the stack from the image should be in place to cope with networkd as an ifupdown replacement. We want to start validating that this cycle, not wait till next cycle.
So you would then just choose whether you use one or the other by enabling networkd and disabling ifupdown or vice versa?
At the individual developer level, I think it should be a configurable option that you opt in. I don't know whether this is something that we want to expose in things like Curtain or MAS to have it configurable, but we may have, for instance, we might have some proof of concept images where networkd is in place, has replaced ifupdown, or we might find, for instance, that the snappy images will be ready to transition earlier than other cloud images or classic server images, for instance.
Yeah, so sorry, that's what I actually meant. Like when MAS installs a machine, then it would either enable networkd or it would install ifupdown. Not necessarily that a human needs to do this, and we certainly shouldn't expose it in the configuration. If we are already at the point where we abstract it in YAML, and we certainly should not expose the implementation details. Because at that point, it's an implementation detail, as far as I understand.
Right, and I just think that Curtain should cope with the images, which it's going to need to anyway, right? Because Curtain, as a tool, supports installing both older stable releases and should work with installing the latest release. So it should cope with outputting either ifupdown or networkd-config according to what it's installing to. And I think that ideally it would be able to detect what the image it's installing uses rather than hard coding based on release, or possibly just emitting both of them on every system. Right. I mean, the only consideration there is we've just talked about how we're not necessarily teaching networkd and ifupdown to not step on each other, right? Well, we might do that in the image itself. Yeah. But that's something we need to make sure, since networkd is present in all different images, we need to make sure that adding both networkd and ifupdown config out to the file system doesn't break things.
Well, I assume that's just a matter of enabling and disabling some systemd services, I hope, or some units.
Yeah, well, the point is that this is existing Vivid images that have already been released.
Well, for the record, we install networkd by default, but it's not enabled by default. Like, neither networkd nor resolved are enabled, so you have to explicitly do this right now.
Okay. So that's fine. If that's the case, we can just take care of it at the image level.
Yeah, that's basically shipping to symlinks, so it's not a big deal to enable it, but it needs to be done at the moment, explicitly. Because for that very reason, I mean, ifupdown is still what we install by default, and it doesn't have an off switch, so we rather don't want to accidentally ramp over your network config right now.
Tom, I have a couple of questions about the dbus API for modification.
Yep.
Once you guys have that,
yep,
will networkd then update the files on disk to match, or will it be out of sync?
Oh. Sure, it will. Okay, so the plan there is to do similar thing as what we support with unit files that you can update, or you can have either persistent or what's it called, ephemeral changes. So either you basically what you can do, you send your new configuration over dbus, and then it will write out either a file to run, which means it will be gone next boot, or it write out a file to etc, so it will stay around for next boot.
Okay. And if a user comes along and uses the IP command to mess around with the network config, will networkd at any point notice that and reset it, or
we will track it and we will follow it. We will update our internal state, but we will not, as a matter of principle, we don't second guess the user or external tools.
Okay.
So if you create some device or if you make some changes, we leave them alone.
Okay. Cool, thank you. Sorry to help me.
So I have a question. In networkd, if you wanted to change an interface, could you bring down just one interface, change it in the config file, and then bring it back up, or is that not possible right now?
Right now, it's not possible. Now you cannot. Well, okay. So what you can do is to shut down networkd, bring down the interface using IP command, and then restart networkd after you change. Oh, sorry. Shut down networkd, change the config file, bring down the interface, and restart networkd, which is a hack for development purposes. But for end user, basically we say it's not supported.
Okay, that would just be reversing where we are now, or where we were in 1404, which is okay. Cool.
That seems kind of unfortunate. It's kind of a very useful thing to be able, on a server, to be able to safely mess around with just one interface, knowing that you're not going to lock yourself out of the server because you're not messing with the interface you're SSH to. Yep. And unless I misunderstood you just said that's essentially not a supported operation.
Yep, correct. That's unfortunate. So we absolutely want that, and we need it, and it's something that will come as soon as we have either we have KDBus or we give up waiting and just do it anyway.
Oh, I see. Sorry, I thought you were saying it was like the hooks that you weren't willing to support.
No. This is something we must have, yeah. Sure.
Well, since
so that sounds like something.
Sorry.
Go ahead.
No, that's fine.
I was just going to say, that sounds like something that would be a blocker for adopting this by default, because I think that for servers, when you're administering, well, okay. We could probably switch Cloud and Snappy over to it, because all of your configuration is fed in from the outside.
Right.
So we know in those cases people are not making changes to those images in place, but for the classic server use case, it seems that we do need to have that support before we would switch.
Well, so Cloud is all usually boot time, but not always. Snappy, however, many of the Snappy use cases are all about doing things like building routers where you want to be logged into one interface and screw in with the other.
What does screen mean here? Like you want to dynamically change the .network file to have different settings and then apply them, or screw them on the command line?
It doesn't mean necessarily screwing it on the command line, but it does mean that you, as part of the functionality of the device, if it's a router, you need to be able to make changes to the network configuration. Adam's right.
Right, and I mean, to be fair, a lot of consumer routers do get around this very poorly by allowing you to change the entire network configuration and then rebooting and see what happens. But frankly, from a Debian and Ubuntu perspective, I consider that a massive backward step, because we currently have this ability to actually let you mangle one interface without rebooting, which is nice, or without restarting everything else.
So I didn't follow that. So why can't you just shut down that like network control? They stop that interface or that .network file and then start it again?
So for me, so we just don't have the DBus API. It's actually a trivial thing to add. So
right.
If this is the blocker, I mean, I could do it, or I easily accept patches for it. So it's not a big deal. It's just the hookup isn't there.
So at least for core Snappy, we do need the DBus API. I mean, there's no other way we can actually let snaps or frameworks on top just be moving files around in the rootfs, right? So we do need a mediatable way to control this. That's the DBus API. So I guess it really depends on what the time frame for that is, right?
So my original plan was to, as I said, wait for KDBus and then do it. It wouldn't take long, a few weeks, I guess, most. Or if there's a pressing need, we could change it around and just do it straight away without KDBus. But yeah, so if people post patches, I'll merge them. I mean, no problem.
Yeah. So per our earlier System D roadmap discussion that we had a session earlier today, KDBus is not really something that we would be able to depend on in the 1604 timeframe, because some of our use cases include containers that have to be able to run on older kernels on host systems running previous Ubuntu LTS releases.
Okay.
So in order for this to solve our problems for 1510 and 1604, it would need to be something that didn't depend on KDBus.
Okay. It's doable.
I have one question. Sorry if this was covered somewhere else or earlier, but I don't think I've seen it covered. What's the long-term plan with regards to networkd Network Manager? Because essentially it looks like there's two pretty much competing technologies from the same company, which seems a bit odd. Is there a two men enter, one man leaves type scenario, or do you think they'll continue to coexist forever?
I'm not sure. I'm not privy to the long-term plans. For the moment, we are focusing networkd on the server case and the container case, and of course we extend it where it makes sense. But we haven't. I don't know what the long-term plans versus network manager is.
I guess that would become more relevant once networkd actually does get a DBus interface, and you can do stuff like up or down and network configuration through DBus, and hence through like an indicator on your desktop.
Yeah, it doesn't really make sense to discuss it yet, but until we see. At the moment, they're not equivalent at all. So Network Manager does a lot of stuff that we don't do at all. So there's not really any point in discussing it yet. So we haven't.
Actually, I guess that's another use case. It's somewhat tangential, but a bunch of the Internet of Things devices are going to have 3G to be mobile and all that kind of stuff. Would there be an option to have Network Manager on Snappy? Like, how would that work?
That's like a Phono plus Network Manager then? Yeah. I mean, there is nothing in principle that would stop someone from creating a framework with Network Manager and the Phono underneath, and then like applications can talk to that, I guess. I think that the main issue is that you have to make sure that they don't step on each other and configure the same interfaces.
Right.
So it's a more fundamental problem.
So today, when you install Network Manager along ifupdown, Network Manager has this ifupdown awareness, and I think it's quite nice. But I suspect you want to invest in having a Network Manager or a networkd snap that is used during the first boot to help people getting started, kind of the out-of-the-box experience for end-user-facing devices. But in other cases, like maybe for, let's say you have this network operating system and you're installing a switch, it won't come with Network Manager. I mean, you probably will have directly the network OS installed that drives the whole network stack. I guess it kind of depends on the target device, and for Snappy there'll be a range of different cases. What I think we're looking for the end-user experience is having a simple way to have a Chromecast-like user experience where on the first boot there's a Wi-Fi being set up that allows you to set up your device, and when it's set up, the network is reset to whatever you set it up to. So, I don't know, it comes up with a Snappy Wi-Fi. You can use a Snappy Wi-Fi, you set up your config, and then it connects to your actual home Wi-Fi or office Wi-Fi or whatever, like modern devices would do. So we could implement that with Network Manager, and the benefits would be that I think that it models this stuff, but it also has like a DBus interface. Or we could implement it with networkd, which seems like lighter weight, but also like less beautiful and less complete in terms of advanced features, which we don't really need the advanced features right now, but it might be useful.
Okay, well, I guess, do we have any other, well, let's check our RC for a sec, but if there are any questions.
Mostly just discussions about inventing time machines.
Oh, well, why didn't we get that yet? Okay. So I don't see any questions there. So yeah, I guess if we don't have any other topics, then I guess we can wrap that up. So we do have a couple of work items and things to investigate, so that was very useful. So thanks again, everyone, and thanks, Tom.
Thank you.
Yeah, thanks very much, Tom.
And yeah, okay, well then, have a good night, I guess. Yeah, thank you.
Yeah, thanks, everyone.
Bye-bye.
Thank you. Bye-bye.
Bye.